Did you know that Mars might be burping? Yes, you heard that right. Methane plumes have been detected on the red planet, and they're raising more questions than a toddler on a sugar high. But what's the deal with this Martian gas? Let's get our lab coats on and find out. The discovery of methane on Mars, particularly by NASA's Curiosity rover in 2013, has sparked a whirlwind of intrigue and debate among scientists. Methane, a simple molecule composed of one carbon atom and four hydrogen atoms, is a significant player in the quest for understanding not only Mars but the broader universe as well. On Earth, methane is predominantly produced by biological processes, such as the digestion of food by animals, including cows and other ruminants. This raises an exciting question. Could the methane detected on Mars also be a sign of life? Or is it merely a product of geological processes, such as the breakdown of rocks and minerals? The debate between biological versus geological sources of methane is one of the most thrilling aspects of Martian research. Methane is often seen as a potential biosignature, a hallmark of life. However, its presence could also indicate geological activity, making it essential to explore both avenues of possibility. To understand the significance of these methane plumes, we must first delve into the chemistry behind them. Methane on Mars has been observed in varying concentrations, suggesting that it is not uniformly distributed across the planet. The Curiosity rover detected spikes in methane levels in specific regions, hinting at localized sources. This variability could reflect seasonal changes, geological activity, or even the presence of subsurface water. On Earth, methane is produced in large quantities in wetlands, landfills, and during the digestive processes of animals. However, the Martian environment is vastly different, characterized by its thin atmosphere and frigid temperatures. One intriguing aspect of Martian methane is its relatively short atmospheric lifetime. Methane can decompose in the presence of ultraviolet light from the sun, breaking down into carbon dioxide and other compounds. This means that if methane is continually being produced, it would need a source that replenishes it at a rate that matches its decomposition. This continual cycle raises questions about the processes at play on Mars. Is there ongoing geological activity that generates methane? Or is there a biological source that remains hidden beneath the Martian surface? The potential for life on Mars is a tantalizing prospect. The idea that microbial life could exist in the subsurface, thriving in conditions we might consider inhospitable, adds a layer of complexity to our understanding of the planet. Methane could be produced by methanogenic microorganisms, which thrive in anaerobic environments, breaking down organic matter to produce methane as a byproduct. If these microorganisms exist on Mars, they could represent a form of life that has adapted to extreme conditions, offering insights into how life might exist elsewhere in the universe. On the other hand, the geological processes that could produce methane are equally fascinating. Mars has a history of volcanic activity, and some scientists theorize that ancient volcanic eruptions could have released methane trapped in the planet's crust. Additionally, the interaction of water with certain minerals, particularly olivine, could generate methane through chemical reactions. This geological perspective opens up a different avenue of exploration, suggesting that Mars is a dynamic planet with processes that could be generating methane even today. As we ponder these questions, it's important to consider the implications of finding methane on Mars. If the gas is of biological origin, it could indicate that life exists or once existed on the planet. This would not only change our understanding of Mars, but could also reshape our views on life in the universe. Conversely, if the methane is purely geological, it could reveal new insights into the planet's history and its potential for hosting life in the past. The discovery of Martian methane plumes is like opening a door to a world filled with possibilities. Each plume could be a clue, a small piece of a much larger puzzle. The complexity of space research often feels like a never-ending rabbit hole, where each discovery leads to more questions than answers. As scientists continue to study Mars, they are not just searching for signs of life. They are also unraveling the intricate tapestry of a planet that has fascinated humanity for centuries. In our quest to understand Martian methane, it's essential to recognize the limitations of our current knowledge. While we have made significant strides in exploring Mars, many questions remain unanswered. The tools and technology we use to study the planet are constantly evolving, and each mission brings new data that can shift our understanding. The Curiosity rover, for instance, has been instrumental in analyzing the Martian atmosphere and surface, but it is only one part of a larger exploration effort. Future missions, such as the Mars Sample Return mission, aim to bring Martian soil and rock samples back to Earth for more detailed analysis. As we continue to explore the chemistry of Martian methane plumes, we must also appreciate the humor in this situation. After all, Martian methane plumes could be seen as the universe's equivalent of a cat's hairball, unexpected, puzzling, and a little bit messy. The idea that Mars, a planet often depicted as barren and lifeless, could be burping methane adds a layer of personality to our understanding of the red planet. It challenges our perceptions and invites us to think creatively about what life might look like beyond Earth. In conclusion, the chemistry of Martian methane plumes is a captivating topic that intertwines the search for life with the study of planetary geology. As we unravel the mystery surrounding this gas, we are not only learning about Mars, but also about the fundamental processes that govern our universe. The questions raised by the presence of methane on Mars are profound and far-reaching, inviting us to ponder our place in the cosmos. So as we continue our exploration of Martian methane, let's keep our minds open to the possibilities. Who knows what secrets this enigmatic gas might reveal? So what have we learned? Martian methane plumes are not just the universe's best-kept secret, but possibly Mars' way of saying, "I had too much pizza last night." Who knew the red planet had such a gaseous personality? And remember, whenever you think of Martian methane, just picture a cat cleaning up after a particularly indulgent meal. The exploration of this topic is not just about understanding a planet. It's about understanding the very essence of life and the universe itself. With each discovery, we step closer to answering the age-old question, are we alone in the universe? The Martian methane plumes offer a glimpse into a world that is both familiar and alien, challenging us to explore beyond our boundaries. As we continue to study Mars, let us embrace the mysteries it holds, for they may one day lead us to answers we have yet to even consider. The chemistry of Martian methane plumes is a reminder that the universe is full of surprises, and as we delve deeper into this topic, we uncover not just the secrets of a distant planet, but also the very essence of what it means to be human.